Now let's talk about theories and hypotheses. Science seeks to develop theories. Theories are really sets of facts and relationships among those facts that can explain and predict phenomena. It begins with generating hypotheses that are systematically tested. Hypotheses are not rejected, I should say, contribute to the theory and then help generate new hypotheses. Scientists construct the best possible model of reality based on the facts that we have to date. So the best scientific theories not only explain and organize known facts, but they also tend to generate new predictions. A scientific prediction is a lot more than a guess or a hunch, but it's based on an awful lot of previous work, previous literature, and previous experimentation. So before generating your scientific questions, it usually pays to become really familiar with the previous theories and discoveries that are out there. So Sir Isaac Newton once said, "Scholars stand on the shoulders of giants," meaning we build on the work of those who came before us. Specifically, he said, we stand on the shoulders of giants. That's why we're able to see so far. Combining your own observations with past work and theoretical foundations in your field, you can then generate a hypothesis. That hypothesis is an educated guess. As I mentioned, it's based on prior evidence, logical possibilities, and your own observations. So science often progresses when a gifted observer recognizes sort of deeper meaning in an everyday occurrence. So there are some things about these hypotheses that in order for them to be scientific, they need to adhere to. First, they need to be falsifiable and they need to be testable. So what I mean by falsifiable is that you can imagine a situation that would show that your hypothesis was false. An example of that is a hypothesis claiming that all planets outside our solar system are uninhabited is falsifiable. Because if we found just one inhabited planet outside our solar system, that would show that your hypothesis is wrong. So the thing is, though, you can never really prove a hypothesis is true. Because, for example, imagine some future experiment, possibly using new technology, maybe it's not currently available, that might show the hypothesis is false. So all we can really do is show when a hypothesis is false. A false hypothesis must always be modified or discarded once it's shown that it's false. So this is kind of how it works, a very simple schematic here. You come up with some hypothesis, theoretical hypothesis, for example, a causal mechanism, mathematical relation, something of that sort. That yields a prediction, and then that leads to theory. So in this case, here's a theoretical hypothesis that suggests a testable prediction, and then that leads to some systematic observation through experimental or non-experimental means. So here's what a hypothesis is. It's a proposed explanation for a situation, like if A happens, then B will be the result. And the theory would be, if we had several of these hypotheses, for example, a set of facts and relationships between facts that can explain and predict related phenomena. In psychological research, we use that scientific method to test ideas about behavior. The scientific method really comprises a set of rules for gathering and analyzing information. It enables us to do things like test ideas or hypotheses, and the decisions made at each step of this method tends to affect the types of conclusions that one can draw about behavior.